Hello and welcome to a screencast on determining formulas for exponential functions. From our previous studies, we know that if a certain function is linear, then we can determine the function's formula as long as we know 2 points that lie on the line. More recently, we introduced exponential functions such that g of x equals ab raised to the x power, where a and b are both positive constants and b does not equal 1. It turns out that exponential functions are similar to linear functions in one way. Knowing 2 points on the graph of an exponential function is enough information to determine the function's formula. In the following example, we will show how knowing 2 values of an exponential function enables us to find both a and b exactly. Suppose that q of t is an exponential function, and we know that q of 3 equals 75 and q of 7 equals 101. Determine the exact values of a and b for which q of t equals ab raised to the t power. Since we know that q of t equals ab raised to the t power, the 2 data points given to us can be used to write 2 equations in the unknowns a and b. So first, using t equals 3, ab to the 3rd power equals 75. And using t equals 7, we have ab raised to the 7th power equals 101. We know that the quotient of outputs of an exponential function corresponding to equally spaced inputs must be constant. Therefore, we can consider the quotient 101 divided by 75. Using the 2 equations we just wrote, it follows that 100 divided by 75 equals ab to the 7th divided by ab to the 3rd. Simplifying the fraction on the right, we see that 101 divided by 75 equals b to the 4th. And solving for b, we find that b equals the 4th root of the quantity 101 divided by 75 as the exact value of b. Note that we are only using the positive 4th root because the base b is defined to always be positive in exponential functions. Now, to find the exact value of a, we solve one of our original equations for a. So let's just take ab to the 3rd equals 75. And solving for a, we can see that a equals 75 divided by b to the 3rd. Substituting the exact value of b, we see that a equals 75 divided by the 4th root of 101 over 75, quantity cubed. We can leave this as is, or we can use properties of rational exponents, and we could rewrite this as a equals 75 divided by 101 over 75, quantity raised to the 1/4 power, so that 4th root turned into a 1/4 power, and then all of that raised to the 3rd power. And then using properties of exponents again, we could say that equals 75 over the fraction 100 divided by 75, quantity raised to the 3/4 power. So an exact formula for q of t is q of t equals 75 divided by 101 divided by 75, all raised to the 3/4 power, and then that is multiplied by the 4th root of 101 over 75, which is raised to the t power. An approximation for q of t is q of t equals 59.9952 times the quantity 1.0772 raised to the t power. And a plot of y equals q of t confirms that the function we found indeed passes through the points 375 and 101. I would take a moment to pause the video and notice how we entered the values of b and a exactly into Desmos and then used those quantities to define q of t to graph an exact function for q of t. In the next video, we will look at trends in the behavior of exponential functions.